So I'm going to start on lesson 3, which talks about associations with categorical data. And we're going to basically talk about the expected value of the table. So here we have 1,000 city residents were asked if they should ban smoking or do not, and they also recorded data on if those residents were male or female. And the results are shown below. So here's actually the expected value on the table. So what do you notice and what do you wonder? Well, what am I noticing is males who banned smoking was 252, but the expected value was 266. So the number of males that were expected to ban smoking were more than actually occurred. Same thing with females. 312 were in favor of banning smoking, but only 297 were expected. So the amount of females was over the expected value. And then here for not banning smoking, more males than expected were in favor of not banning smoking, and more females or less females than expected were in favor of not banning smoking. So those are just some of my noticings and some of my wonderings. So I might wonder also, how did these numbers get here? How do you calculate the expected value? We're going to find out that that's just the row total times the column total divided by the grand total for each column. So this is 473 times 564 divided by 1,000. So this expected value might be significantly different, but how high or low, how much bigger or smaller do those numbers have to be? And we're going to look at the actual number later. So we're going to talk about how these are calculated here and figure out those values. So if I wanted to figure out the expected value for males that do not want to ban smoking, we take the row total, 473, divided by the column total, or times the column total. So I'm just going to put star 436, and then divided by 1,000. And then that gives us our 206.228. Then here for females, we do the row total, 527, times the column total, 564, divided by 1,000. And that gives us our 297.228. And then here, to calculate that, we do the row total, 527, times 436 divided by 1,000. And then that equals 229.772. Now, for the rest of these, I'm actually going to have you calculate them. So here you would get your row totals. So 61 plus 20. Oftentimes in a table, these columns aren't even made, so you'll have to make them. So 61 plus 20 is going to equal 81. And then here, 21 plus 58 is going to equal 79. And then here, 61 plus 21 is going to equal 82. And then here, 20 plus 58 is going to equal 78. Then if I add these, 81 plus 79 gives us 160. So for racquetball, for males, we would do 81 times 82 divided by 160. And I'm using a calculator, 81 times 82 divided by 160. And that gives us 41.5125. And then here for exercise studio, how many males want an exercise studio? You go 81 times 78 divided by 160. And I'm just showing my work here too, so that you can see what I did for the calculation. So 81 times 78 divided by 160. And that gives us 39.4875. And then here, this would be for females, 79 times 82 divided by 160. And that gives us 40.4 4875. So here, this would be 79 times 78 divided by 160. And that gives us 38.5125. So now to convert these, and then again, we would look at is there a significant difference? Now in looking here, the expected value is 40, but the actual one is 60. Here we have 21, the expected value is 40. All four numbers are really above or below their expected values. So all four cells in the table are significantly different than the expected value. Then you might wonder, how do you measure the significance? And we're going to talk about the chi-square statistic next. So now we're going to practice a frequency table. So to do this, we just do 61 for males that like racquetball divided by the grand total of 160. So 61 divided by 160 gives us 0.38125. I'm just going to round that to 2 decimal spots, so 0.38. And then for exercise studio, it's 20 divided by 160. And that gives us 0.125 or 0.13. And then here, this would be 21 divided by 160. And that gives us 0.13. And then here, this would be 58 divided by 160. Is about 0.36. So to just practice making a relative frequency table. So next, what we're going to do is talk about the chi-square statistic to test for a significance in association. So what you do is you take the actual value minus the expected value in parentheses, and you square it and divide it by the expected value for each cell in the table. So here we do 252 minus 266.77 squared divided by 266.77, and then just keep adding these parts. So I do the same thing here, 221 minus 206.23 squared divided by 206.23, and then plus here we would go 312 minus 297.23 squared divided by 297.23. Keep doing that, and then this gives us 3.56. Now, to be significant, you have to be larger than 3.841. So since our chi-squared statistic is not larger than 3.841, this is not, the data is not significantly different, which means males and females do not have a significant association of wanting to ban smoking or not. It's a very strong association, but it's not significant. And we'll talk about that a little bit later. So here for our exercise studio, what I can do here, remember we had these numbers right here. So I'm just going to take them, copy them, and paste them here. And then we're going to practice calculating the statistic. So what I'm going to do here is just delete how it was calculated. And now to do my statistics. So what I do here, and I'm not going to show it with the fancy math type. I'm just going to go, this is 61 minus 41.51. And And then for squared, I'm going to just put caret key 2. And then I would divide that by 41.51. And then I add on the next part. Now, really, I need this in my calculator to get the statistics. So I do need to put that in specially. And I'm doing that 61 minus 41.51 squared divided by 41.51 plus, and then here I go 20 minus 39.49 squared divided by 39.49 plus, so again, I add that piece in, and I go here 20 minus 39.49 squared divided by 39.9 plus, and then here we go 21 minus 40.9 squared, and then divided by 40.9, and then plus, putting that in my calculator to work along with you. Again, I'd use a calculator for this. So 21 minus 40.49 squared divided by 40.49 plus, and then our last part of it is going to be in parentheses 58 minus 38.51 squared divided by 38.51, and all of that is going to equal, when we do this, let me just get that last piece in my calculator, 58 minus 38.51 squared divided by 38.51, and then that gives us 38.01. Now remember, this is significant. We just had to be above 3.84. So there is a significant association. So it's way above 3.81, so it's very significant. So I'm going to let you guys do this one. So figure out the expected value and then find out the chi-squared statistic, and then also work with your practice problems. So now what I'm going to do is show you, well, R does this actually pretty easy. So we can put in these datas. So if you look here, I made my statistics of females and males who want to ban smoking and not. And then I just put in here XSQ, and then I did a chi-square test of the data. And then what I can do, if I wanted to, I could look at the chi-square value. So XSQ to see what it shows. So again, it says my statistic is 3.32. I have 1 degree of freedom. My p-value is 0.06. Remember, to be significant, it has to be below 0.05. And then this is actually really cool. You can find the expected table right here. So you can go chi-squared money sign expected, and it'll show you the expected value. So in looking at data 1, I can run that matrix in here for males and females that like racquetball. And then I can do a chi-square test. If I want to look at the value of that, I can do XSQ. And notice it's 36.81. And then I can also find my expected value by doing that chi-squared money sign / expected. And then if I wanted to do my column, I do the total is a sum of the row sums of data 1 and the data divided by total. And I can get a real quick relative frequency table. And then here to perform a chi-squared test, we just put in our money or put in our table, do the data, run the chi-squared test. Here's our expected value and find the statistic, which I showed you before. And then here's our other one. So for data 2, row names, column names, put those in there. Do the table of data 2, find the chi-squared test, find the expected value table, show the chi-squared test. Here's our third one, which I wanted you to practice on your own. So you just put in the matrix column. Remember, you put in the columns of the table. So as I go back to the table here, you'd put this in as the concatenation of parentheses 22, 81, comma, 78, 19, and then you just put close it and then put ncol equals 2 for there's 2 columns. And then you just change the row names, which you really don't have to if you don't want to. And then here's the table with those names. Then you can find the expected value after you run your chi-square test. And it lists the numbers that are expected, and then you can actually run the chi-square test. So this is a significant difference. And when your p-value is this small, it's 5.14 times 10 to the negative 6, you would just say the p-value is less than 0.001. So now I want you to practice the practice problems and then also struggle a little bit with the check for understanding.